All right, we're about to dive into some of our planet's most mind-bending features. Impossible lakes. Yeah, you heard that right. These are bodies of water that seem to defy the very laws of science we thought we understood. So you might want to forget everything you know about calm, blue water, because we're about to explore lakes that explode, turn animals to stone, and exist where they should be frozen solid. So before we get into the really weird stuff, let's just quickly set the stage. We all have a picture in our head of what a normal lake is, right? It fills a basin, it's fed by rivers or rain, and it follows these predictable rules of geology and climate. It's a stable, understandable system. But what happens when a lake just decides to throw out the rulebook? What happens when water stays liquid where it should be frozen solid? Or when life thrives in a chemical soup that should dissolve it? Or when a perfectly calm surface is hiding a catastrophic secret? Well, those are the impossible lakes we're exploring today. Our first stop is one of the most isolated and just mysterious places on Earth, Lake Vostok. This is a massive liquid ocean, and it's hidden deep beneath the Antarctic ice sheet. Okay, so here's the core paradox, the thing that just shouldn't be possible. On the surface, temperatures can drop to some of the coldest ever recorded anywhere on the planet. But if you go 4 kilometers straight down, through solid ice, there's a liquid, freshwater lake the size of Lake Ontario. Logically, this water should be nothing more than a solid block of ancient ice. And get this, scientists think Lake Vostok has been completely sealed off from our atmosphere, from sunlight, from any weather for at least 15 million years. It's a pristine time capsule from a totally different era of Earth's history. And here's the twist that gets scientists so incredibly excited. Despite the crushing pressure, the total darkness, and the extreme isolation, they've found DNA fragments that suggest microbial life could actually exist down there. This makes Vostok a perfect natural laboratory for understanding how life might survive in the subsurface oceans of icy moons, like Jupiter's moon Europa. So, how is this even possible? How does it stay liquid? Well, it turns out it's a combination of 3 things working together perfectly. First, you've got a faint geothermal heat rising up from the Earth's crust. Second, the immense pressure from all that ice on top actually lowers the water's freezing point. And third, that same ice sheet provides the perfect insulation, trapping all that heat below. It's a crazy balancing act. Okay, let's now travel from the freezing cold to the burning heat of Tanzania. This is Lake Natron, and it's a body of water that seems to turn life into stone. The water here is basically a caustic soup of sodium carbonate salts. It's so corrosive that animals that die and fall into it are preserved in this eerie, calcified state. They look like ghostly stone statues. It's a truly surreal and, frankly, deadly landscape. To put this in perspective, a pH of 12 is incredibly alkaline. I mean, it's nearly the same as household bleach. In water this caustic, proteins should break down, cell membranes should just dissolve. Life shouldn't be possible. But, and this is the incredible paradox, this seemingly lethal environment is actually a sanctuary. That caustic water keeps predators away, which makes it the perfect protected breeding ground for millions of flamingos. They thrive here, right alongside unique bacteria that actually give the lake its otherworldly red and orange colors. With the intense heat and evaporation in this part of the world, this place really should just be a dry, cracked salt flat. But it's not. It's kept in this delicate, stable balance by mineral-rich springs and ash from a nearby volcano, which are constantly replenishing its unique and deadly chemistry. Our third impossible lake is a beautiful, serene body of water in Cameroon that's hiding a terrifying secret. This is Lake Nyos, the lake that can literally explode. The best way to think about Lake Nyos is like a giant can of soda that's been sitting completely still for decades. Deep below the surface, volcanic vents are constantly seeping carbon dioxide into the bottom layers of the water. And because the lake is so deep and still, that gas gets trapped and dissolves under immense pressure, just waiting for something to shake it up. In 1986, something did disturb that delicate balance. The soda can was shaken. The lake violently released a massive cloud of CO2. We're talking 1.2 cubic kilometers of it. That gas cloud silently flowed down into the surrounding valleys, suffocating over 1,700 people and thousands of livestock. It was a silent, invisible disaster. Now, here's the most terrifying part. You'd think this was a one-time event, right? But it wasn't. After the disaster, the lake just started recharging itself. The volcanic vents kept pumping CO2 into the depths, slowly rebuilding the exact same conditions that led to the catastrophe in the first place. It's a natural system that rebuilds its own ticking time bomb. This cycle is what makes the lake so scientifically baffling and so dangerous. The volcanic CO2 seeps in, gets trapped by the dense water, the pressure builds, and then it just waits for a trigger. Now, degassing pipes have been installed to make it safer, but the lake's natural tendency is to return to this incredibly unstable state.
So what do we learn from all this? I mean, these aren't just geological oddities. They are natural laboratories that are literally forcing us to rewrite the rules of science.
Let's just put it all together. You have Lake Vostok, which challenges our whole understanding of where liquid water and maybe even life can exist. Then there's Lake Natron, which redefines the absolute limits of what life can tolerate. And Lake Nyos forces us to rethink what stable even means for a geological system. Each one of them breaks a fundamental rule. So why does this matter? Because these lakes prove that stable, liquid water and potentially life can exist in conditions we once thought were completely impossible. And if it can happen here, on Earth, in these extreme environments, it just expands the range of places we should be looking for life elsewhere in the universe. Ultimately, these impossible lakes show us that our own planet is more complex, more dynamic, and far more creative than we often give it credit for. They prove that sometimes the most exciting science is found where the rules get broken. And it leaves us with this final thought. Earth's hydrological imagination is far greater than our own.